Okay guys, today's lesson in section 5.4 is over trig functions of any angle. So we're going to start to put together some of the concepts that we've been talking about as well as add in some new ones. And we're going to start to be able to travel outside of the first quadrant in order to find exact value. So everything that we've done up to in chapter 5 up to this point is going to come into play today and also moving forward. Okay, so example 1, we have a point on the terminal side of an angle theta in standard position at the point -15, 8. So -15, 8 is the point on the terminal side of the angle. And so what I'm going to do is I'm going to draw a picture with that point, and I know that that point is in quadrant 2 because -15, 8. -15 is the x-coordinate, 8 would be the y-coordinate, and so that means that this distance is going to be 8, and then this distance is going to be -15, and then I'm going to draw a hypotenuse that goes back to the origin. So I drop a little perpendicular line here, and then a line that goes back to the origin so that I make a right triangle. Okay, and then I'm going to find the other side of this right triangle using Pythagorean theorem. So Pythagorean theorem says 8 squared plus -15 squared is going to equal to r squared, and I'm going to use r to mean radius here because next class we're going to put all of this into a circle that has a radius of 1. Right now the radius doesn't have to be 1, but that's why I'm using the letter r. Okay, and so if I go ahead and calculate that, 8 squared plus -15 squared, make sure that you put the negative in parentheses in your calculator when you calculate it, and I'm going to get 289, and that's going to equal to r squared, and it turns out that that's a perfect square, and so r is going to equal to 17. Okay, so I'm going to put a 17 here on my hypotenuse. So now to find the 6 trig functions, I know that sine theta is going to be opposite over hypotenuse, and my theta is always going to be right here next to the origin. So opposite over hypotenuse is going to be 8 divided by 17. All right, well that tells me what cosecant theta is because I know that's just the reciprocal. Oh, excuse me, so 17 over 8. Okay, cosine theta is going to be the adjacent side over the hypotenuse. So here's my adjacent side, -15. Here's my hypotenuse, 17, so -15 over 17. And that tells me also that secant theta is going to equal to -17 over 15, since I just take the reciprocal. And then finally, tangent theta I know is going to be opposite over adjacent, and so opposite is going to be 8, and adjacent is going to be -15. So I can just write that as -8 over 15. And that tells me that cotangent theta, the reciprocal, is just going to be -15 divided by 8. Okay, so put your point in the right quadrant, find the hypotenuse using Pythagorean theorem, and then find the 6 trig functions the way that we normally do. Okay, example 2 is very similar. This time we have 6 -4, and so if I draw a picture here, 6 -4 is going to be the point right here in the 4th quadrant, and so that means that this distance right here is going to be -4, and this distance is going to be +6, and then I'm going to draw a line that goes back to the origin and put my theta right there. Okay, and I'm going to call my hypotenuse r, and then I'm going to find what r is. So that's going to be 6 squared plus -4 squared is going to equal to the hypotenuse squared. And so if I do 6 squared plus 4 squared, that's going to be 52 equals to r squared. And then I'm going to simplify that radical whenever I take the square root, because I know that 4 will go into 52 13 times. And so that's going to end up being 2 square roots of 13. So 2 square roots of 13 will be my hypotenuse. Okay, so when I do sine theta is going to be the opposite side, which will be -4, over the hypotenuse, which will be 2 square roots of 13. So that'll be -4 over 2 square roots of 13. And then you just want to simplify the 4 and the 2. So that's actually going to be -2 over the square root of 13. Okay, well that tells me what cosecant is. So cosecant, let me erase this so that I write it a little bit more clearly. Cosecant theta will just be the reciprocal, and so that will be negative square root of 13 over 2. Okay, cosine theta is going to be the adjacent over the hypotenuse, so the adjacent is going to be 6 over the hypotenuse, which is going to be 2 square roots of 13. And again, we're going to reduce. 6 over 2 becomes 3 over 1. So 3 over the square root of 13. And then secant theta will just be the reciprocal. So that would be, what? Square root of 13 divided by 3. Okay, and then finally, tangent theta is going to be the opposite over the adjacent. So opposite from this angle theta is going to be negative 4. The adjacent is going to be 6. So negative 4 over 6. I'm going to go ahead and reduce that to negative 2/3. And that means that cotangent theta is going to be negative 3 divided by 2. Okay, one of several definitions that we want to talk about today is coterminal. Okay, so the first definition we're going to mention is coterminal. And basically, coterminal angles end up in the same place on the coordinate plane. They might be different numbers, but they would end up in the same place. So like just to give you an example, let's say in the first quadrant I have 30 degrees here. Well, a coterminal angle would be like if I had that same angle that had gone around one time first. And so if it goes around one time first, I know that that's going to be 30 degrees plus 1 revolution. And so that would give me 390 degrees. So I can get coterminal angles by either adding or subtracting 370 degrees or 2 pi radians if we're talking about an angle that is in radians. So if I wanted to get another angle that was coterminal to 30 degrees, I could just add 360 again, and that would give me 750, I believe. Okay, so that's kind of the idea is you can either add or subtract 360 degrees, and that ends up being the same angle, no matter if you're adding or subtracting. Okay, so we want to use this idea of coterminal angle to find exact values without a calculator. So in part A, we have the cosine of 390 degrees. Okay, well, I know that 390 degrees is a big angle. And so what I want to do is I want to find a coterminal angle by subtracting 360 degrees, and that's going to give me 30 degrees. So what that means is that this is now equal to just the cosine of 30 degrees. And you should have cosine of 30 degrees memorized from your table. Take a second to remind yourself that that would be the square root of 3 over 2. Okay, letter B, same thing. I have 420 degrees. I want to find a coterminal angle with that by subtracting 360, and so that would give me 60 degrees. And so that means that this tangent of 420 is really just the same thing as tangent of 60 degrees. And again, that's an exact value that you should have memorized from your table. It should be the square root of 3. Now, letter C is a little bit different because it's in radians. So I know that in order to get a coterminal angle in radians, we could subtract 2 pi. Well, in order to subtract those, we need to have them be the same denominator. So 13 pi minus 6 pi over 3, that's the same thing as 2 pi, and now they have the same denominator. So that's going to give me 7 pi over 3. Well, that's still not an angle in the first quadrant. So I'm going to subtract 2 pi again, which again is going to be like 7 pi over 3 minus 6 pi over 3. And that's going to give me 1 pi over 3. Okay, so what that means is that back up here, this is the same thing as cosecant of pi over 3. And that's something that you should have memorized. And so remember, cosecant of pi over 3, that's just the reciprocal of sine of pi over 3. Sine of pi over 3 is square root of 3 over 2. And so the answer to this question is going to be 2 over the square root of 3. So now that we have coterminal angles, I can start to ask you to find exact values of expressions where the angle is not necessarily between 0 and 90 degrees or 0 and pi over 2. It might be a coterminal angle to an angle that's in that first quadrant. Okay, on this slide, we want to talk about how do we figure out what the sign, S-I-G-N, of each of the three, or really each of the six trig functions are in each quadrant. So there's a nice little acronym that we can use to help us remember this. In quadrant 1, all six of the trig functions are going to be positive. So we use an A, and that A stands for all. In quadrant 2, sine is positive, and so I'm going to use S to represent sine being positive. Of course, if sine is positive, that means that cosecant is also positive, since those are reciprocals, and all the others are negative, and so that S is going to stand for star. In the third quadrant, tangent is positive, which also means that cotangent, since it's the reciprocal, would also be positive, and all of the others are going to be negative. And that T is going to stand for trig. And so that means in the third quadrant, tangent is positive, and everything else is negative. And then in quadrant 4, cosine is positive, so I'm going to use a C, and that C is going to be stand for class. And so that just means that in the fourth quadrant, cosine is positive. Everything else is negative, except, of course, for secant, because secant is the reciprocal of cosine. But all four of the other functions are going to be negative in quadrant 4, other than cosine and secant. So if you can remember all-star trig class, that will help you remember which trig functions are positive or negative in which quadrant. And all-star trig class would represent the ones that are positive, and then you just kind of fill in the blanks for which ones are negative. Okay, so just kind of putting this new knowledge to the test, we want to name the quadrant in which each angle lies. And so if I just draw a little coordinate plane here with all-star trig class, then I know that sine of theta being positive, that's going to happen in quadrant 1 and quadrant 2. Cosine theta being negative, well, that's going to happen wherever I don't see an A or a C. So that would be in quadrant 2 and in quadrant 3. That's where cosine theta is going to be negative, because cosine theta is positive in quadrant 1 and quadrant 4. And so which quadrant shows up on both lists? That would be quadrant 2. Okay, in letter B, kind of the same story. This time I want cosine to be positive. And so that's going to happen in either quadrant 1 or quadrant 4. And then cotangent to be negative. Well, I know that if cotangent is negative, that means that tangent theta is also negative. And tangent is going to be negative in quadrant 2 and quadrant 4. Quadrant 2 and quadrant 4. So again, the quadrant that's showing up on both of those lists would be quadrant 4, which normally we use Roman numerals, so that's why I'm using Roman numerals, but 4 would be okay also, probably. I think on the online homework, though, you'll have to respond in Roman numerals. Okay, the next important concept we want to discuss are reference angles. So here's the definition of your reference angle. Okay, so definition, reference angle. And a reference angle, there's two important things here that you need to realize. A reference angle is always an acute angle. And so what that means is that the reference angle is always between either 0 and 90 degrees or between 0 and pi over 2 radians. That's what it means to be acute, either between 0 and 90 or 0 and pi over 2. Formed by the terminal side of theta and the x-axis. So that's the other important thing about reference angles, is that they always go back to the x-axis. Okay, so hopefully these two pictures will sort of help you to see what we mean by a reference angle. So like, for instance, if I were to just draw a little picture here, and then I draw an angle here in quadrant 2, then the angle that goes back to the x-axis, the small one, is going to be here. So this would be my theta reference, or my reference angle for that particular angle. If I were to do something in quadrant 4 would be here. And so my reference angle would be the smaller angle between that angle and the x-axis. Remember, the x-axis is here. And so my theta reference would be that angle right there. Okay, so this is going to be one of the major skills that we do for the next couple of chapters. So we're going to need to make sure that we know how to find reference angles. And so what we're going to do, first of all, just to get us started, is draw the angle where it goes. So I know that negative 55 degrees is going to rotate clockwise, and it's going to end up in the fourth quadrant. So this is negative 55 degrees. The reference angle is going to be the angle back to the x-axis. And so since the angle back to the x-axis is literally just the angle that I made, the answer here to this is going to be positive 55 degrees. Now you might be wondering why it's positive 55 and not negative 55. And the answer for that is that the reference angle is always positive. Remember we said on the previous slide that all of these reference angles have to be between 0 and 90 degrees, or they have to be between 0 and pi over 2 if we're talking about radians. Okay, letter B, 135. I know that 135 is going to be in quadrant 2, so this is 135 degrees. And so my reference angle is going to be here. It's going to be that short angle that goes back to the closest x-axis, which in this case is 180 degrees. And so if I want to figure out what this reference angle right here is, I just need to subtract 180 minus 135, and that's going to give me the reference angle of 45 degrees. In letter C, we have 308 degrees. I know that's going to be in quadrant 4, so this is 308 degrees. And my reference angle is going to be the shortest way back to the x-axis. So that's going to be right here, and that x-axis is represented by 360 degrees. And so to find my reference angle, I'm going to take 360 and I'm going to subtract 308, and that should give you 52 degrees as your reference angle. Okay, things can be a little bit more challenging in radians, so we've got 4 problems here that we can practice in radians. And so remember, to figure out what quadrant this in, it's good to write it as a mixed fraction. So 7 over 5 is the same thing as 1 2/5 of a pi. And so if I think about where that's located, if I go to 1 pi, that's going to be here, and then 2/5 is going to put me short of this line right here, since that would be a half. 2/5 is smaller than a half, and so I'm going to be in quadrant 3. My reference angle then is back to the x-axis, and so back to the x-axis is just going to be 1 pi, and so the difference between this angle, 7 pi over 5, and 1 pi, which would be like 5 pi over 5, is going to be 2 pi over 5. Okay, so hopefully that is making a little bit of sense. For 5 pi over 6, I know that 5 pi over 6 is smaller than 1 pi, so that's going to put me in quadrant 2. My reference angle then is going to be back towards the x-axis, which is right here. And so that x-axis is being represented by pi, or another way to think about it is 6 pi over 6. And so the difference between 6 pi over 6 and 5 pi over 6 is going to be pi over 6. And that's going to be the reference angle for the given angle in letter E, pi over 6. Okay, for letter F, we have negative 130 degrees. So remember, that means that we're going to rotate clockwise. So negative 130 is actually going to put me here into quadrant 3. And the closest x-axis is going to be the one that is right here, which is being represented right now by negative 180 degrees. And so the difference between those two places is going to be positive 50 degrees. Okay, letter G, negative 5 pi over 3. So remember, this is the same thing as negative 1 2/3 of a pi. So negative 1 pi would get me to here, starting at 0, of course, going clockwise. And then negative 1 2/3 would actually put me past this right here, which would be like negative 1.5 pi, if you'll remember. And so I'm going to be in quadrant 1. That means my reference angle is just going to be this angle right here, which is the difference between negative 2 pi and negative 1 2/3 pi. And so the difference between 2 and 1 2/3 is going to be 1/3 of a pi. So you've got to be pretty good with fractions in order to be able to do this. And so that's kind of why we're practicing here with radians. Okay, so the difference between 1 2/3 and 2 would just be 1/3. So pi over 3 would be our reference angle. Now for 11 pi over 3, that's actually going to be the same thing as 3 2/3 of a pi. So if we think about 3 2/3 of a pi, 1 pi is going to get me here, 2 pi is going to get me here, and then 3 pi is going to get me here, and then another 2/3 of a pi is actually going to put me in quadrant 4. And so this is going to be quadrant 4 right here, this 11 pi over 3. So the reference angle is going to be this angle that goes back to the x-axis. Well, remember, this x-axis could be represented as 0, it could be represented as 2 pi, it could be represented as 4 pi, which really 4 pi is the same thing as 12 pi divided by 3. And so now you can see that the difference between these is just 1 pi over 3. So again, the reference angle for letter H is going to be pi over 3. Okay, letter I, negative 226 degrees. So negative 226 degrees is going to put me into quadrant 2. So this is negative 226. Negative 226 degrees. The closest x-axis is back this direction. And so that's going to be represented by negative 180 degrees. And so the difference between those two angles, I believe, is going to be 42 degrees, if I'm not mistaken. So just take 226 and subtract 180 in order to get the difference there, 42 degrees. Okay, this slide might take a while to explain, but I'm going to hopefully do this as quickly and as thoroughly and clearly as I possibly can. What we're going to do now is not use a calculator, but be able to figure out what each of these things are using the quadrant that the angle is in. That's going to tell me the sign of the answer, the reference angle, so we practiced that on the previous slide of finding the reference angle, and then also we're going to need the chart that you should have had memorized for your last test. Okay, so all of those things are going to get put together. This is kind of like putting all of the puzzle pieces together to answer this question. Okay, so we'll start with letter A, sine of 330 degrees. Well, I know that sine 330 degrees is in quadrant 4. What that means is that because it is sine of 330 degrees, sine of 330 degrees is going to be negative, because if you remember all-star trig class, in that fourth quadrant, cosine's positive, which means that everything else is negative. So my answer here is going to be negative. Now, my reference angle, if I just draw this real quick, quadrant 4 here, 330, the closest x-axis is here, so that reference angle is going to be 30 degrees. And so this is just going to be the same thing as sine of 30 degrees. And if you draw out your chart, sine of 30 degrees is going to be a half, and so the answer to sine of 330 degrees is going to be negative a half. Again, it's negative because 330 is in the fourth quadrant, and in the fourth quadrant, sine is negative because of all-star trig class. And then the reference angle is 30 degrees, and sine of 30 from our chart is equal to a half. So if you put those two things together, you get the answer, negative a half. Okay, letter B, sine of negative 45 degrees. So I know that negative 45 degrees is again in quadrant 4, and quadrant 4, sine is negative. So I know that the answer is going to be negative. Now the reference angle, if I draw negative 45 degrees just real quick, negative 45 degrees is here, and so the reference angle is going to also be 45 degrees. And so what I need to know from my chart is what is the sine of 45 degrees. And so you should remember that that's square root of 2 over 2. And so the answer to this, without my calculator, is going to be negative square root of 2 over 2. All right, letter C, cosine of 5 pi over 4. So 5 pi over 4 is actually in quadrant 3, because remember, it's like 1 1/4. 1 1/4 is a little smaller than 1 1/2. And so because this is in quadrant 3, that means the answer is going to be negative, because cosine in that quadrant is negative. If you think here, all-star trig class, okay, in quadrant 3, tangent's positive, but cosine is negative. And so I know the answer here is going to be negative. Now, radians, when we do exact value, are very easy because finding the reference angle is incredibly easy. All you have to do is look at the denominator. So the denominator is 4. That means the reference angle is pi over 4. And so what we need to know now is what cosine of pi over 4 is. And I know from my table that that's square root of 2 over 2. So putting everything together, the answer to cosine of 5 pi over 4 is negative square root of 2 over 2. Okay, letter D, tangent of 16 pi over 3. So the toughest part of this will be figuring out what quadrant this goes in. And it might be helpful to do a coterminal angle. So I'm going to use coterminal angles here, 16 pi over 3. I'm going to subtract 2 pi. And so that's going to get me to 10 pi over 3. I'm going to subtract another 2 pi, so that would be another 6 pi over 3. That's going to get me to 4 pi over 3, and that's a much easier angle to know what to do with. So 4 pi over 3 is going to be the same thing here. So I'm going to rewrite this problem as tangent of 4 pi over 3. Now, 4 pi over 3, that's the same as 1 1/3 pi, so that's going to put me in quadrant 3. And I know that in quadrant 3, tangent is positive. So my answer here is going to be positive whatever the tangent of pi over 3 is, because tangent of pi over 3 is the reference angle. And the way that I know that is because radians are super simple. To find the reference angle, you just have to look at the denominator. So tangent of pi over 3 from my list, from my chart, is square root of 3. And so I know the answer to letter D is going to be square root of 3. Okay, letter E, tangent of 135. So I know that 135 is in quadrant 2. According to all-star trig class, tangent is going to be negative in quadrant 2. So I know the answer here is going to be negative. And now I need the reference angle. Degrees are a little bit tougher, so I'd have to actually draw the picture here. This is 135. This is going to be 180, and my reference angle is between those two. And so if we take the difference there, that's going to be a reference angle of 45 degrees. And so what we really need to know now is what the tangent of 45 degrees is. And from our table, I know that tangent of 45 is 1. And so the answer to letter E, putting everything together, is going to be negative 1. Okay, letter F is a reciprocal secant of 2 pi over 3. Okay, so 2/3 of a pi I know is going to be in quadrant 2. In quadrant 2, I know that sine and cosecant are positive and everything else is negative. So I know the answer here is going to be negative. Okay, the reference angle, super easy. Because it's in radians, I know that it's going to be pi over 3. And so what we really need to know is what secant of pi over 3 is. Well, in order to know what secant of pi over 3 is, I got to know what cosine of pi over 3 is, because that's the reciprocal. Cosine of pi over 3 is equal to 1/2, and so the reciprocal of 1/2 is going to be 2. So to put everything together, we're going to get the answer of negative 2, okay, because it's in quadrant 2, which cosine is negative there, which means secant is also negative there. And then the reference angle is pi over 3. I know that secant of pi over 3 is 2, and so that means the answer to F is going to be negative 2. Okay, cosecant of negative 60 degrees. I know that negative 60 degrees is going to be in quadrant 4. In quadrant 4, cosine and secant are positive. Everything else is negative, so I know the answer to this is going to be negative. My reference angle, if you draw it real quick, negative 60 degrees is here. If I go back to the x-axis, that's just going to require me to go 60 degrees, so the reference angle is going to be 60 degrees. And so we need to know what cosecant of 60 degrees is, which really means I need to know what sine of 60 degrees is, and then take the reciprocal. So sine of 60 degrees is going to be the square root of 3 over 2. And so if I take the reciprocal of that, that's going to be 2 over the square root of 3. And so putting everything together, along with the negative sign and the actual value from the chart, we get negative 2 over the square root of 3. Okay, letter H, cosine of 7 pi over 4. I know that 7 pi over 4 is really the same thing as 1 3/4 of a pi, which is going to put me in quadrant 4. And in quadrant 4, I know that cosine is positive because of all-star trig class. Okay, so I know that my answer here is going to be positive. My reference angle Well, I just have to look at the denominator, so that's going to be pi over 4. And I know that cosine of pi over 4 from my chart is square root of 2 over 2. So the answer here is going to be positive square root of 2 over 2. Okay, and then finally letter I, negative 5 pi over 6. Negative 5 pi over 6 is actually going to be in quadrant 3 because it's a little smaller than negative pi. Okay, negative pi would be here, and so that's going to put me in quadrant 3. And in quadrant 3, I know that sine is negative, so I know that the answer here is going to be negative. The reference angle is pi over 6, so reference angle pi over 6. That means I need to know what sine of pi over 6 is, and sine of pi over 6 is 1/2. Therefore, the answer to letter I is negative 1/2. Okay, so hopefully that's enough examples for it to make it clear. If not, then definitely we can talk about it more when I come back to class. Okay, I like this example because it's going to reinforce some of the things that we've been talking about during this lesson. So find the exact value of tangent of 65. Okay, well, I'm going to try to get everything in terms of tangent of 65 if I can. So let's see maybe what we can do here as far as like reference angles and sines go. So for tangent of 65, I know that tangent of 65 is in quadrant 1. So I'm just going to leave that as tangent of 65. Now for tangent of 100, 100 is in quadrant 2. Okay, so there's a reference angle for that. And then I also know that because it's in quadrant 2, I can make this negative. So I'm going to go ahead and write this as minus, and I should probably do all of this down here. So I'm going to come down here and do tangent of 65 minus tangent of, and then I'm going to find the reference angle for 100 degrees. And so the reference angle for 100 degrees, since 100 degrees is in quadrant 2, it's here. That means I'm going to be going here for my reference angle. That would be 80 degrees. Okay, plus tangent of 260. So I know that tangent of 260 is going to be in quadrant 3. And all-star trig class tells me that that's going to be positive, so I'm going to keep it positive. And the reference angle for 260 is going to be here. This is 260. That would take us back to 180, and 260 minus 180 is going to be 80. So that's going to be the same thing as tangent of 80 degrees. And then 295 is going to be in quadrant 4. So 295 is going to be here. I know that in quadrant 4, tangent is negative, so I can go ahead and write this as negative tangent. And then I'm going to do the reference angle, which is here. Remember that this is 360 degrees. And so the difference between those is going to be 65 degrees. And what you notice is that this problem turns out really nice because everything is about to cancel out. So tangent of 65 minus tangent of 65 cancels, and negative tangent of 80 and tangent of 80 cancel. And so the answer to this whole thing is equal to 0. Okay, on example 8, we want to find the possible values of theta between 0 and 360 with the given trigonometric value. So we want tangent theta to equal square root of 3 over 3. The first thing we need to figure out is what reference angle from our chart is going to give us a tangent of square root of 3 over 3, and I know that that is going to be 30 degrees. The next thing we need to figure out is what quadrants we need to be in, and so this square root of 3 over 3 is positive, so I need to figure out what quadrants is tangent positive. And so from all-star trig class, just writing that down again, that's going to be quadrant 1 and quadrant 3. So we're going to be in quadrant 1 and quadrant 3. Okay, so what angle in quadrant 1 has a reference angle of 30 degrees? Well, that would just be 30 degrees. If you draw just a quick picture, I want an angle in quadrant 1. I want the reference angle to be 30 degrees. So obviously, that's just going to be 30 degrees. So that's going to be one of our answers here. And then the other answer is going to be in quadrant 3. So I'm going to draw an angle here in quadrant 3. I want the reference angle to be 30. And so I know that this is 180. So if I want to go an extra 30 degrees from 180, that's going to put me at 210 degrees. And that's going to be the other answer to this particular question, is 210 degrees. So again, I got quadrants 1 and 3 because I want to know where is tangent positive, because this was a positive number in the question, positive root 3 over 3. Okay, for letter B, we want to first of all figure out the reference angle. So we need to figure out what reference angle gives us a sine value of a half. And so if you look at your chart, once again, you'll see that that is going to be 30 degrees. Sine of 30 degrees is a half. And so now I want to figure out what quadrants I'm going to be in. Well, this time we have a negative number for sine, and I know that sine is a negative number in quadrant 3 and quadrant 4. So the objective now is to figure out what angles in quadrant 3 and 4 have reference angles of 30. So if I draw a little picture here, I'm going to draw an angle in quadrant 3 with a reference angle of 30 degrees. I remember that this is 180 degrees, and so to figure out what this entire angle is, I'll use a different color here. To figure out what the entire angle is, we just need to add 180 and 30, and that will give us our first answer of 210 degrees. Okay, my pen is not working real well there, but hopefully you're getting 210. I'm obviously saying it, so 210 degrees is going to be our first answer. Okay, our second answer is going to come in quadrant 4. So here's quadrant 4. I want the reference angle again to be 30 degrees. And so if this is 360 degrees, this time what I'm going to do is I'm going to subtract 30 degrees from 360. And so that's going to give us our other answer of 330 degrees. Okay, so these problems will more than likely have two answers when you go to answer them. Okay, in example 9, we're going to find the exact value of each of the remaining trigonometric functions of theta if cosine theta is negative 5 over 13 and theta is in quadrant 3. So what I'm going to start off by doing is drawing a picture. I'm going to draw an angle here in quadrant 3. So here's my theta, and I want cosine of this theta to be negative 5 over 13. So I know that cosine is adjacent over the hypotenuse. So that tells me that the hypotenuse is going to be 13, and the adjacent side is going to be negative 5. Now, the hypotenuse is always going to be positive. So if there's a negative in the question, it's always going to go with one of the sides, either the opposite or the adjacent. It's never going to go with the hypotenuse, so just as a heads up. Okay, so we need to find our other side. We need to find our opposite side, so let's call it A if we want to. Here's my right angle, and so to find it, we're going to do negative 5 squared plus A squared is equal to 13 squared. So that means that 25 plus A squared is going to equal to 169, which means that A squared is going to equal to 144, and so A is going to equal to 12. Now you got to be real careful when you write 12 on your triangle here, because it might be positive and it might be negative. So if you take a look here, this is on the negative y-axis. So that means this is going to be a negative 12. Okay, so just pay attention there to what you're doing. Since we're in quadrant 3, I know that this side right here has to be negative. Okay, so sine theta I know is going to be opposite over hypotenuse, so that would be negative 12 over 13. That immediately tells me what cosecant theta is, so that would be negative 13 over 12. Cosine theta was given in this problem, so we know that it's negative 5 over 13. That means that secant theta, its reciprocal, is negative 13 over 5. And tangent theta is going to be the opposite over the adjacent. So our opposite is negative 12, our adjacent is negative 5. You can go ahead and reduce those to positive 12 over 5, and that means that cotangent theta is going to equal to the reciprocal 5 over 12. Okay, example 10 is very similar to example 9, except this time they say that tangent theta is 3/4 and that sine theta is negative. So they didn't explicitly tell me what quadrant I'm going to be in. They're going to make me think about it for just a second. So I know that tangent theta here is positive and sine theta is negative. So if I think about all-star trig class, where is tangent positive and sine negative? Okay, hopefully you said quadrant 3. So here I'm going to draw a line in quadrant 3 that represents the angle theta, and then draw a perpendicular back to the x-axis, and so here's my right triangle. I want tangent theta to be 3/4. So I know that tangent is opposite over adjacent, so the opposite side is going to be 3. But again, be careful. That's going to be a -3 because it's on the negative side of the y-axis. And then the adjacent side is going to be 4. But again, be careful. It's got to be -4 because it's on the negative side of the x-axis. So the sign, S-I-G-N, really does matter here. Now, to find the other side, that would be the hypotenuse. So we're going to do -3 squared plus -4 squared is equal to r squared. And so that's going to be 25 is equal to r squared, so that r is going to equal to 5. And remember I said earlier that the hypotenuse will always be a positive number. Okay, so now we're ready to find all of the trig functions. So sine theta is going to be opposite over hypotenuse, so that would be -3/5. And that means that cosecant theta is going to be -5/3. Cosine theta is going to be adjacent over hypotenuse, so that would be -4/5. That means that secant theta is going to be the reciprocal, -5/4. And then finally, tangent theta, which was already given in this problem, so we just write it down as 3/4. And then cotangent theta is going to be the reciprocal, which is 4/3. Okay, you guys let me know if you have any questions on anything from section 5.4.